Welcome to Java Objects and Classes. So we're going to look at objects and classes in Java, and they are the core concepts. And these concepts are fundamental in understanding how Java structures and manipulates data, and also it explains how it allows us to model real-world problems and solutions efficiently. Definition of a class. So a class in Java basically acts as a blueprint for creating objects. It outlines the state represented by attributes or fields, and behavior represented by methods and that the object created from the class will possess. So you can basically think of a class as a template from which individual objects are made. And if you look at this example, this example defines a simple class named car. This class does not contain any fields, methods, or constructor. It's right now a blueprint ready to be detailed. Components of a class. So in a class, fields define the properties of the objects, like the color of a car or the balance of a bank account. So methods define what actions the objects can undertake, like to give an example, like accelerating a car or depositing money in an account. So constructors are special methods called when an object is created, setting up its initial state. If we look at this example, we have this car class, and it now includes one field called brand and one method called display max speed and one constructor. And the brand field stores the car's brand. The display max speed method prints a message to the console saying the max speed is 200 kilometers per hour. And this constructor initializes brand to unknown when a car object is first created. Creating a class in Java. So if you're to create a simple car class, which you already saw, this class includes fields for brand and max speed and a method to display this information. So one thing to keep in mind is when we are defining this class, we're not creating a car. We're just outlining what information a car should contain and actions it can perform. Constructors in Java. So constructors initialize new objects, and a default constructor is called when an object is created without explicit parameters. A parameterized constructor allows us to set initial values, and overloading constructors enable different ways to initialize objects, so we get some flexibility there. So let's look at this code example. This is the same car class. This class demonstrates two types of constructor. The first one is a default constructor, And this default constructor sets the brand unknown and max speed to 0. And the parameterized constructor, unlike the default constructor, it allows the creation of a car object with specific brand and max speed values provided at the creation time. Definition of an object. So an object is an instance of a class. That means we talked about class being a blueprint. If we were to continue using that analogy, an object would be a house built from that blueprint. So each object has its own set of fields and methods defined by its class, but can hold different values. So objects are the fundamental building blocks in Java and object-oriented programming. Creating objects in Java. So in order to create objects in Java, you use new keyword. So for example, let's say you're creating a new car object, then creating a new car object involves specifying its class and using new to allocate memory for it. Once created, you can access its attributes and methods, which are defined in its class. So this example, we are initializing a new car object with the brand Toyota and a max speed of 200. Accessing object members. In order to interact with an object, you need to use the dot operator. This allows us to access the object's fields and methods. So, for example, after creating a car object, we can set its brand or ask it to display its information using the method defined in the car class. So if you see this print line, it's calling brand directly using the dot operator. Here's another example. This example creates two car objects with different attributes and call their display method, which is called display info. This example shows how we can instantiate objects from the same class, but with different states, and how we can interact with them. In conclusion, so it is important to understand classes and objects because they allow us to encapsulate data and behavior, create reusable code, and model complex problems. Thank you everyone for listening.